Bismillahirrahmanirrahim. My name is Ramanjit, and today in this video I will cover lab number 5 uh, of topic introduction and interfacing an LCD liquid crystal display and hex keypad with Atmega using Atmos Studio and Proteus. Objective overview of controller to controller communication to understand LCD interfacing with microcontroller, hardware interfacing of LCD with Atmega 328P or Arduino 2560 microcontroller. Equipment that we use in this lab are AVR, Atmos Studio Proteus 8 Professional, Arduino IDE, Arduino 328P or Arduino 2560, 16 cross 2 LCD panels, 1 kΩ resistors, 5 kΩ variable resistor, breadboard, 1 microfarad capacitors. Introduction LCD is used to interactive LCD provide textual information from microcontroller. It makes application in microcontroller modes come in various configurations such as 20 cross 20, 16 cross 1, 15, 40 cross 1, 16 cross 2, 16 cross 4, 5 cross 11. LCD control unit. LCD controller is responsible for all operations within LCD such as movement of cursor, display, carrier. LCD controllers in internal memory comprises character generator ROM, character generator RAM, and display data RAM. Symbol VSS is a ground pin, VCC main power supply, VE power supply to control is RS register selection, RWV right pin, enable pin, DP0, DP1, DP2, DP3, DP4, DP5, DP6, DP7 display letters or numbers. Zeros reports are sent to data pins. LED plus for backlight, VCC LED negative for backlight ground. LCD function. The following functions must be defined for proper working of the LCD library. To define these pins, LCD 8 set cursor and LCD 4 set cursor. This function will set the configuration, LCD write character and LCD write character. These functions will write a single character to the LCD screen, LCD write string and LCD 8 write string. These functions will write string on or text to the LCD screen, and the cursor positions will be incremented by length of string plus 1. LCD communication modes. There are two communication modes in an LCD: 4-bit communication mode, 8-bit communication mode. So this is the interface of 4-bit mode, and this is the interface of 8-bit mode. So lab tasks. So write a C program in Atmos Studio to interface a 16 cross 2 LCD with the microcontroller in 8-bit mode. So this is the code that we write. Now we open it in Atmos Studio. So this is our Atmos Studio. In this code, we just add the standard header. After that, we define the SCQ, which is a 1600 1600 then we use the library of LCD. After that, translate our code starts, in which we just made a function of LCD, in which we write data uh, 0. Now again we write data 0. After that we again write data 0. After that again we write data, then we write data 2 to display on LCD. So here is the Proteus of our LCD. So in which you can see that all the 8 bits are connected to the microcontroller. Here is the this is not so in this task we can see that all the uh, LEDs all the bits or 8 bits are connected to the microcontroller. Here is the VCC and here is the oscillator. You can see that, and you can see that the here is the potentiometer, and now we can upload the next file on it. So the relation rate. So this is a simulation of our lab number 5. Task 1. Now we come to the protein simulation. So this is a protein simulation that we can previously due to some error on the proteins. It cannot show the real display that we did in the lab. So this is the screenshots that we added Proteus Proteus and Virtual Studio. So you can see. So, so typically in this lab is that in this lab we learn about this. An LCD we use LCD to for more to see how to practice display. We design the library for LCD to work with our credential library. The library has different several functions necessary for LCD to read or process the data being given to it. So this is the LCD that the file of LCD. So you can see that this is a hardware file that we made by ourselves, and we define the LCD. After that, we give task to the AVR header, and then we give delay header. After that, we make a 4 as input for the which key is the value of 4 is equal to 0 to 0 1. We give the delay of 1, we give 4C is equal to V. After that, we put as input with the delay of 10 milliseconds. After that, we initialize functions by the commands. Commands with the delay of 100 milliseconds. After that, we shift right by using the Y function. Wide shift L, we shift left by using wide function in which I is equal to 0, I is smaller than 0 and I plus plus. And so we made this library on our Advanced Studio. So uh, this is a conclusion of our lab. We designed a library for LCD to work with our coding language. This library has different several functions necessary for LCD to read or process the data being given to it. This is all from lab number 5, and I also have a video of one of my groupmate who sends me it on WhatsApp. That we write a program of Hello World to display it on LCD in our lab. So we just made a code of Hello World to display on LCD. So this is the code. So this is the video in which we display Hello World on our LCD using all the 8 bits and using also backlight. So you can see that the LCD is working and displaying Hello World on it. And if we want to print another words, we can simply do that by changing some lines in the code. So you can see that we can also change the uh, uh, code by changing our lines. You can also you can also observe the new change in the LCD after changing the code. So you can see that code is uploading on the board. So you can see that we change the so you can see that we change the code, and now it displays hello world. This is our program. As this is 16 bits, so it is not displaying the full length of the string. So we want to display here hello world. This is our program, but this is 16 bits, so it cannot display us full string. So this is a video of hardware. So that's all from micro lab number 5. Hope you like the video. Allah Hafiz.